Hey guys, here we are looking at another video. In it, we're focusing on the law of sine and cosine. So, first example we're focusing on here is two markers A and B are on the same side of a canyon rim that are 56 feet apart. A third marker C is located across the rim. Is positioned so that the angle between marker C, A, and B is, or the measure of angle A, is 72 degrees, and the angle between C, B, and A, or the measure of angle B, is 53 degrees. So find the distance between marker C and marker A. Okay, so we've gone through how to use law of sine, law of cosine. Here, we're only focusing on law of sine, so we know we're going to be using that. So we also examined how we create diagrams. So this is a surveying problem, so we're looking at having an aerial view. So it's better, we're talking about some canyon. Let's just draw a nice canyon right here in front of us. All right, so that's our canyon, okay guys? So on one side of the canyon, we have A and B. We're not really given much more as far as where they're located on that canyon, just that they're located on the same side, and that they are located 56 feet apart. So then we have some sort of our marker C on the other side. So again, on this side we'll place marker C, and we have our 3 points to make the triangle. We are then told, and it's from contrast, we're then told that angle A is 72 degrees, and angle B is 53 degrees. And we desire to know the distance between marker C and marker A. All right, so we have our diagram. Slide this up just a little bit. So we have our diagram. If I wanted to, I could draw it nicely on beside, just without the canyon there. We know we're using law of sine. If I didn't know that we're using law of sine already, we have two angles, and right away, if I have two angles, that's law of sine, which we know by this point. Law of sine, we need to find a third angle measure. So when we take the 180 and subtract the two that we know, we find that angle C is 55 degrees. Okay, that's important because we need it to compare to 56. So sine of 55 to 56, and if we desire to know this length, we need its opposite angle, which would be 53, to, we'll just question mark. All right, so from there you can cross multiply and get your solution. All right. So not that bad. Everything was pretty straightforward. Drawing the canyon helped us there get a better idea of where stuff should be placed. Looking at the next. So two people look up into the sky and they saw Superman flying. So Bart saw Superman at an angle of elevation, and Diana saw Superman at a different angle of elevation. So you've seen this before already. If you've examined the little discussion with drawing diagrams, this was there. So we know that there are multiple ways of drawing this diagram because of the lack of detail. But we're going to use, for this discussion, we're going to use the first of the three that I presented, knowing that the last one, didn't work. So the first one that we saw was we have Bart and Diana. And then we have the angle of elevation of Superman. And then we have the angle of elevation for Diana. So here they're looking towards each other. So the angle of elevation at Bart is 65. The angle of elevation at Diana is 80. So, and we know the distance between them is 125. All right. So knowing automatically, two angle measures, law of sine, if I did not know that already. So the top angle, do the quick math for us here. The top angle is 35 degrees. You can check it yourself. But we desire to know to compute the distance between each person and Superman. So we desire to know the distance from Bart to Superman and the distance from Diana to Superman. We have two problems, actually it's going to be three problems to solve. So setting this up, I might write it like this. Sine of 35 to the 125. I'm going to write it as sine of 80 to x. Then I'm going to say equal to sine of 65 to y. Now, yes, I have three fractions here. When we cross multiply, I'll look at the first two, cross multiply them, get our value for x. Then when I desire to find the value of y, I'll just imagine that this fraction's out here. We will cross multiply and get the value of y. So when you get the value of x and y, you should find that the value of x is approximately 214.6200 feet, and the value of y is approximately 197.5124 feet. All right, I wouldn't tell you those in this lesson, in this quick video, if we didn't need them to find the height of Superman, Superman's height above the ground. So when I draw that height, when I place that within the triangle, many have trouble seeing this, but we have split the triangle down the center. Now, we cannot assume that this is bisected as well, okay? Because as a matter of fact, it's not bisected. And a couple of reasons why it's not bisected. Well, the two side lengths are not congruent, and if they were congruent, then possibly the top angle is bisected. But that's all in geometry properties and whatnot. Here, I don't even need to know the top angle. I can just look at one of these right triangles. Yes, I said right triangles, and set it up from there. So sine of 80, because we don't know the exact value for the adjacent, because the 125 is the whole thing, we don't know this piece, equals hypotenuse over y, which was 197.5124, and solving that, we'll get the value of h. Okay? Now, yes, I could have used the left side and using the value of x there, and we will get this, because of the different angle measure, we will get the same height in either approach. Moving on from this problem. So let's say we have two meteorologists. They're 25 miles apart, located on the east-west road. So when I draw this diagram, I'm actually going to draw them, I'm assuming will be north, south, east, and west. So we have two meteorologists on the east-west road. They're 25 miles apart. Okay, so the meteorologist at the westmost point, so this far left point, sees a tornado at a bearing of 38 east of north. Okay. I can go and connect this over here. So because the bearing for the eastmost point is 53 degrees. All right. So doing this, we know the properties of our, properties of geometry and trigonometry. We know that the angles within, we should find that they equal 52 degrees and 37 degrees. All right, so able to find our third angle measure. Our third angle measure would appear to be 180 taking away the 2. That would be 91. This is our tornado. So you can set it up from there. So the setup, we want to find the distance from each meteorologist. So we're going to find two answers, but to find an answer for one of them, sine of, has to be 91 to 25. Sine of 37 to x. And in the previous problem, I showed you how you can just write the other fraction beside it and go from there. All right, not that bad. Just knowing that the bearings that we're given are not actually within the triangle. On to the last one. So let's say we have a ship is sailing south. Sailing south in navigation, the navigator noticed that the bearing to a lighthouse is 150 degrees. So the very first sentence, yes, it is only 5 words, is very important because that tells us that where our 2 of the 3 points for the triangle are going to be. So we are sailing south. So we are first here, sailing south. My second point would be here. It's very critical. All right. So the bearing to see some sort of lighthouse is 150, so we'll say the lighthouse is out here, is 150 degrees. So bearing, we create our own little compass on top of this point. Bearing for 150 degrees, we about there. Well, we know it's within this region. It's 150. All right, so we sail south. 8 miles per hour for 2.5 hours. Okay, and then at the second location, we have a bearing of 47 degrees. That makes sense why it's 47, because if it was still an obtuse bearing, the lighthouse would be down here somewhere. The lighthouse would be like in this region. I guess that could be possible, believe it or not. Maybe that could be possible for the lighthouse to be down here still. It just means with the 47 degrees that we passed the lighthouse. Through that motion of going south, the lighthouse was passed. So, okay, we only have one angle measure within our triangle. The 150 is not within it, but we can easily see that the adjacent angle is 30 degrees, which would then allow us to find this third angle, 103 degrees. Okay, now find the distance from the lighthouse at the time of the second sighting. So we went the distance here. Be careful. When you go to set this up, notice that this 8 mile is miles per hour. It's a speed. So we need to use the time here to get its distance to pair with the 103 degrees, and to pair with 30, we would have our x. All right, so we have the setups available to you in this video for just a couple of the problems that you'll be practicing. So best of luck continuing this. And if you need to, go back and watch our drawing the diagrams, that lesson that we had. And then if you needed to, even go back and practice law of sine and law of cosine. So I'll see you in the next video, where we will probably be looking at law of cosine and how we can apply that to real situations, surveying, navigation, and whatnot. So see you guys, and until the next video, good luck.